Welcome to the lecture series of Mechanics of Solids. In today's lecture, we are going to solve one more problem on centroid of composite area. So let us start with the problem. So this is the problem given. Let us read it first. Find the centroid of figure shown below. So here one figure is given and we are asked to determine the centroid of this figure. So let us try to solve this problem. Following the step, the first step to solve such problem is to decide whether any axis of symmetry is there or not. Looking to the figure, we can say there is no axis of symmetry in this figure. So we need to work out x bar and y bar both. If axis of symmetry is available, then we don't need to work out one of the centroidal distance. So here we need to work out x bar and y bar both. Second step is to decide the axis of reference. So let us fix the axis of reference. Axis of reference are to be selected in such a way that the figure will remain in the first quadrant. So let us select the axis of reference such a way that the figure remain in first quadrant. So these are the axis of reference. This is x-x axis and this is y-y axis. Next step is to divide the figure in simple geometric shapes. So here we can divide the figure in one rectangle and two semicircle. So let us do it. So looking to the figure, we can divide the figure in these three steps. This is first one, a rectangle. This second is semicircle, and this is one more semicircle. Now let us mark the centroid of these three figures. This is the centroid of first figure. This is the centroid of second figure, and this point is the centroid of third figure. Now the next step is to use the equation of centroid to determine the centroidal distance. So let us write the equation of x bar and y bar. We know that these are the equation to work out x bar and y bar. Now it is required to work out A1, A2, A3, that is area of three shapes x1, x2, x3, that is centroidal distance of centroid of three different shapes from reference y-y axis, and y1, y2, y3 are the centroidal distance of centroid of these three figures from reference x-x axis, means in y-axis direction. So let us work out A1, A2, A3, y1, y2, y3 and x1, x2, x3. We'll start with A1. A1 is the area of this rectangle. We know that area of rectangle is length into breadth. Here the length of rectangle is 6 plus 4, that is 10, and width of rectangle is 3. So A1 that has been worked out as 30 centimeters square. Now let us work out A2. A2 is the area of the semicircle. We know that the area of semicircle is pi r square by 2. Same way, for second figure, the radius is 3. So we'll use the same equation to work out A3. The area A3 has been worked out as 14.14 centimeters square. Now let us work out x1, x2, x3. We know that x1 is the centroidal distance of first figure from reference y-y axis. So it is this much distance. The total width of rectangle is 3. So this distance will be half of it. So x1 has been worked out as 1.5 centimeter. Now let us work out x2. x2 is the centroidal distance of second figure along x-axis, so it is this much distance. Now this distance width of rectangle is known to us, that is 3 centimeter, and the distance of center of semicircle from centroid is this much, and we know that that is equal to 4r by 3 pi. So by calculation, x2 has been worked out as 3.85 centimeter. Now let us work out x3. x3, that is centroidal distance of third figure along x-axis. So that is this much distance. Now we use the same equation that we have used in x2. So x3 has been worked out as 4.27 centimeters. Now let us work out y1, y2, y3. y1, that is centroidal distance of first figure along y-axis. So it is this much distance. Total length of the rectangle is 10. So this will be half of it. So y1 has been worked out as 5 centimeter. Now let us work out y2. y2 is centroidal distance of second figure from x-axis. So it is this much distance. Now we know that this distance is 6 centimeter, that is diameter of third figure, and this distance is the radius of second figure. So we can write this distance as 6, and this is half of diameter 4. So this will be 2. So we can work out y2 as, so y2 has been obtained as 8 centimeter. Now let us work out y3. y3 is the centroidal distance of third figure from reference x-axis. So it is this much distance, and that is half of its diameter, means radius. So this distance is going to be 3 centimeters. Now after getting all a1, a2, a3, x1, x2, x3 and y1, y2, y3, now we equate all the value in the equation of centroid, and let us work out the centroid. So x bar has been obtained as 2.57 centimeter. Now let us equate all the value in y bar and work out y bar. So y bar has been worked out at as 4.81 centimeter. Now let us mark the centroid in the figure. So this is the centroid of the figure, which is at 2.57 centimeter from reference y-axis and 4.81 centimeter from reference x-axis. This way we can solve such problems. So here one more such problem has been given. Here you have to work out the centroid of dam section. You can follow the same step and you can solve the problem. Please solve the problem and give your answer in the comment box. If you have any doubt or query, please write in the comment box. I will be there to help you. Thank you very much for watching this video.